Alright guys, this is where things get maybe a little bit more tricky than what we have been doing. Now we have a mix of all types of compounds, or all types of ionic compounds, in front of us, and we have to be able to name them appropriately. So the first thing we need to do is look at each one and determine, does it have a transition metal? Does it have a polyatomic ion? If so, how does that affect the rules? So looking at the first one, Na2CO3, we can see that there is a polyatomic ion to begin with, so we know we're going to name it that way. Sodium is not a transition metal, so we just name it like we always have. So Na is just sodium. And then we have CO3, which is a polyatomic ion. So if we remember back to our rules for polyatomic ions, we just name them off the list. So CO3 is carbonate. So we'll name this sodium carbonate. Okay. For the next one, we have K and Cl, potassium and chlorine. Well, potassium's not a transition metal, so we just have to name them. Okay. And chlorine is not a polyatomic ion or anything weird. It's just chlorine, so we'll name him as chloride, potassium chloride. Okay. For the next one, we don't have a polyatomic ion, but we do have a transition metal. So remember here, we need to determine our charges by uncrossing and unswapping. And we get iron +2 and chlorine -1. Remember to double check your anion's charge to make sure it's correct, which in this case it is. So now we name it as iron 2 chloride. Okay, looking at this one, zinc and hydroxide. Yes, zinc is a transition metal, but because it's one of the ones that has a definitive charge or a constant charge, we don't need to use Roman numerals, so we'll just name him as zinc. Now, OH is a polyatomic ion. It's hydroxide, so we just name it as hydroxide. So zinc hydroxide. The next one, we have a transition metal, but no polyatomic ion, so we uncross and unswap. Cr +2, fluorine -1. Again, double check your charges. Fluorine is supposed to be -1. So now we name it as chromium 2 fluoride. Okay. Next one, lead is a transition metal. No, it's not in the D block, but if you remember, you were supposed to draw an orange line or orange diagonal line through it on your periodic table to denote the fact that it does act like a transition metal, which means we do have to include Roman numerals on this. So we're going to uncross and unswap, and we get lead +1 and oxygen -1. This is where we double check our charges. Remember, oxygen is supposed to be a -2. Well, what happened to that -2? It must have simplified, which means lead must also be a 2, but a +2. So now we name it. Lead 2 and oxygen is oxide. Okay, looking at our next one, lithium phosphate, or lithium and phosphate. Phosphate's a polyatomic ion. Lithium is just a general metal, so we'll name it as lithium and PO4 phosphate. Okay, we have a transition metal, so we need our charge, so we're going to bring up our charges, so CO +2 and N -3. So nitrogen's supposed to be -3, so now we name this as cobalt 2 nitride. And I don't know why we keep having -2 transition metals. Please remember, transition metals are not always -2. They do vary in charges. From here, gallium and NO2. Gallium is not a transition metal, so we'll just name him gallium. And then NO2 is nitrite, not nitrate. And the last one, beryllium and C2H3O2. This guy looks really scary. He's not. You can find him on your polyatomic ion list. Be is beryllium. And this monstrosity is called acetate. It is what makes vinegar taste like vinegar. Okay. So there are some just reviewing all types of naming for ionic compounds. Let's look at it the other way. So looking at the first one, we have sodium, which we know is going to be Na, and we know its charge is +1. Phosphide, notice IDE, so that means it's just phosphorus off the periodic table with a -3 charge. Cross and swap, and we get Na3P. Okay, look at the next one. Magnesium is Mg +2. Notice this is nitrate, not nitride, so we'll pull that off of our polyatomic ion list, which is NO3 -1. Cross and swap, Mg, NO3, and because we're bringing down a numeric value from the magnesium, we'll put a 2 on the outside. Okay, remember the 2 for polyatomic ions shows that that is the charge of that, or transition metal, I'm sorry, the Roman numerals for the transition metal is charge for the transition metal. Okay, and ITE again tells us polyatomic ion, and that is SO3, -2. Cross and swap, they're both 2, so they'll cancel out, so we get PB, not sure what just happened. We get PB, SO3, and if it makes you feel better, you're more than welcome to put it in parentheses just to have it as a visual. Okay, ammonium. We can search all day on the periodic table for ammonium because it does end in the IUM like most metals do. So it's kind of our job to remember that ammonium is not on the periodic table. It is simply NH4 plus 1 off of our polyatomic ion list. And again, SO4 is sulfate. ATE tells us not periodic table, it tells us polyatomic ion list. And that's -2. So we cross and swap. And we're going to get NH4. We're putting a 2 down by it, so we're going to put it in parentheses and put a 2. And SO4. And again, if you want to put that in parentheses too, just to make yourself feel better, you are more than welcome to. Okay, iron 3 tells us we are dealing with Fe plus 3. Oxide is O minus 2. Cross and swap, and we get, not sure why it's not writing, there we go, Fe2, whoops, try that again, Fe2O3. Okay, again down here, iron 2 is iron plus 2. Bromide is bromine minus 1. And again, notice these are IDE, so that's why we're grabbing them off the periodic table instead of the polyatomic ion list. Cross and swap, and we get Fe, Br2. Okay, calcium oxide, Ca plus 2, O minus 2. Cross and swap, they cancel out, CaO. Magnesium is Mg plus 2. Acetate, ATE, tells us polyatomic ion list, and that's that monstrosity we just looked at, C2H3O2, and it's got a -1 charge. Cross and swap, and we get Mg, C2H3O2, and of course that's in parentheses because we're bringing down that 2 from magnesium, and we put our 2 there. 2 more, and then we're done. Barium oxide, Ba plus 2, oxygen minus 2. Cross and swap, they simplify, so Ba. All right, and last one. So we have lead 4. Note here, this is why lead has to have Roman numerals, because it can be a plus 2 like we see up here, or a plus 4 like we see here. So we have lead, which is Pb. It's a plus 4. Nitrate tells us polyatomic ion, so NO3, and that's a -1 charge. So we cross and swap, and we get Pb, NO3, and of course we have the parentheses because we're bringing down a value, 4. Okay, so that's just kind of a quick practice of all of them. You're going to continue practicing that for the next couple days in class. And you do have a quiz on Friday over all ionic compounds, and it will look something like this, where you have a bunch of names that you have to write out the formula for, and a bunch of formulas you have to write out the names for. If you have any questions, let me know. Thanks, bye.